Hi, in this little tutorial we're going to look at using ncloth and passive colliders and end particles all together with a couple of fields to make this, which is a slightly absurd animation, but to animate a little cell moving along in kind of a totally unrealistic way, and then having these little Cheetos, bacteria, maybe stick to the surface of this thing. So something like this. If I just deselect and play the animation, so you can see we're having this thing move and it's squeezing between a tight space, and also the bacteria have the chance to stick to the surface of the thing as if it's a white blood cell kind of patrolling an area. Again, not really realistic even in the way that it's moving exactly, because it should have more of a leading edge that's kind of pulling it along in this sort of rotation kind of motion. But I'm kind of simplifying it just as an example about how to use ncloth. So we'll go through the setup of all this, and what you'll learn something about is how to make an ncloth object that can do this, how to control its movement using a field, how to include particles like these with instance geometry, and how to make all of these things interact with one another. So let me just save this out and I'll create a new scene. Yes. And we'll just build this up again quickly. So to build this cell, we're just going to smooth a cube, let's say 4 times, and delete its history and freeze its transformations, turn it into an ncloth. The nucleus node, turn on use plane so it has a floor to sit on. Give ourselves lots of frames to work with, and play the animation, and we'll just hit the floor and collapse. So no good. So we want it to have some internal pressure, so it will push out the edges, pardon me, the geometry. And so if we go into this ncloth shape, I'm not naming anything sensibly here, I should do that. If we go into the ncloth shape that's associated with that geometry, we can use one of the presets, something like a beach ball or an airbag or a water balloon or a water volume. All these things have internal pressure, so they won't collapse on themselves. So water balloon, I think, might work well here. It might be a little too active. Right, so we just have to let it go down and settle, and then we can freeze it in that position. If it's taking too long, we can select this in the ncloth shape node under dynamic properties. Under dynamic properties, under damp, we give this some value of damp so it doesn't bounce around so much. Alright, so I'm just going to let it play out until it settles. I'm going to stop, and now when we get into a position that we want, we can select it and go to fields and solvers and initial state set for selected. Now if we go back and play, it starts in this position, right? So set the initial state of something is very useful. Okay, so how do we want to make this thing move? Well, when you are dealing with ncloth, you're giving up a lot of the control that you would have for normally keyframing an object. You can have it attracted to its input mesh. So if you look at this object, if I open up the ncloth menu set, we can say display input mesh, and you can see that's the input mesh that it was originally made from, and you can say display current mesh. So it evaluates the difference between these two things, and you can have it, where is it? Oh, input mesh attract. So you can have the ncloth attracted to the input mesh, and you can try and animate the input mesh around, but honestly, it doesn't work that well. How else can you move this thing around? I'm going to save this before something terrible happens. Ncloth cell. Well, you could use a constraint, I guess, if we selected some vertices. Let's say I just take one vertex for now, and I go to N constraint. I can add a transform constraint to this. I thought I was just about to crash there on me. I can select this, and I can animate this, and it will sort of tug it along in a weird way. So if I just set keys on, let's translate values, let's say over 100 frames or so. I drag it out here, set those keys again. I have no idea what's going to happen. Right, so we can pull it along. So maybe selecting a single vertex to do this is not the best way to do it, because you can see the way it's tugging there, so I'm just going to delete that. So what if we selected a whole bunch of vertices? Again, I'm not sure exactly how this is going to work, but if we do another transform constraint, and here do the same thing, set a key on its position, drag it out here, set another key, right, so that can work. If you wanted to, you could start to play around with the ncloth itself. If you wanted to drag a little more, I don't know, you could make it sticky. See what happens here. Maybe too sticky. So let's try something other than sticky. Let's turn up the friction. See what this does. So that's a little better. It's allowing itself to let go. And what else do we have here? All these different settings. We have its rigidity, its deform resistance. So if we turned up the stretch resistance, like for example, see how that's going to change things. It's not going to allow it to stretch and things will go crazy. Compression resistance, if we turn this up, what will happen here? Well, there's not a lot of compressing going on, so it should be okay. We're getting a different sort of result back here. It's kind of interesting the way it's adhering to the surface and then releasing, which is kind of pleasing in a way. Just trying to select this transform node. So you can change certain qualities about these end constraints, their strength, their glue strength. And glue strength means how likely it is to fail, so these can snap off. The constraint method is a spring, which can stretch but won't compress, like a string. Or pardon me, it will stretch and then it won't compress beyond a spring's ability to compress. A rubber band will stretch and compress, and a weld will do neither. So we can change this to rubber band. See if we get a different kind of result. It might not be that visible here. And what if we turn the strength down? Some very low value. Seems to work just the same, except you'll notice that they're stretching out a little bit. So they're not adhering quite so much. So we turn this down to very low value. So you can see it's pulling before it grabs. Actually, that gives us a slightly better animation. It gives it a little bit of a leading edge with kind of some of the rolling you might see in a cell movement. Maybe my friction is too high. See, when I turn that down now, it just slides over the surface. So at any rate, you can do lots of different things to move a cell, but you're just not, or an ncloth, you're just not controlling it that directly. So I'm just going to delete that constraint. Another thing we can do is to select it and add a field. So we can add like an air field, for example, put it behind it and sort of blow it in the direction that we want to go. So right now the magnitude of this thing is 4, the direction is up in Y, so we want to change this to X, I think. Turn off Y. Give it some more strength, just see what happens. Okay, so it's blowing it along here. It's got an attenuation of 1, so if we turn that to 0, then the effects won't fall off over space. And there you can see it's moving a little more quickly. So that's not a bad way if you want to animate something like this. And you could, set a key on the magnitude. Have it go down to not negative 100, although you could and have it attract to that air. So let's just look at this. So it's pushing it along, and then in a few frames the air field will turn off and it will settle down, right? Okay, so that's good. So I'm going to break that connection, turn this back to 100. And what if you wanted to pass through something, like squeeze between a space? Well, you can do that. Let's say we just create a couple of cylinders. So in addition to ncloths, which are deformable dynamic objects, you can also create what are called passive colliders, which are just rigid bodies that can be animated around to do stuff, but they won't deform when something collides with them. I'm going to duplicate this to make a little gap that it has to get through. So I want to delete the history and freeze transformations on these. Save my scene. I'm going to select these two things and I'll go to ncloth, and rather than ncloth I'll make a passive collider. So let's see what happens now. So these things won't react to the field because they're not linked to the field in any way. So it's going to go through, slowing down, can't fit. Okay, so he's too robust to fit through here. Let's see. What can we do to make it fit through? Well, we could turn up the strength of that field, right? I can turn down the friction. Let's see if that helps. So that's the friction on the ncloth. So that means it's going to slide more on the ground rather than roll. But now it can squeeze through, does a little hop, then it carries on. It lost some of its vigor because it lost its energy by going through there. I also have my compression resistance turned up pretty high. So let's turn the friction back up and let's turn compression resistance down. So it can still stick to the floor, but maybe it will squeeze better. Let's see. Come on. See, the friction is slowing it down. Do we need more air? I think we need more air. There we go. It made it through. But it lost a lot of its oomph when it did that. That's fine. Let's just leave things as they are. You can see that the ncloth, when it's moving, it's kind of getting a little crinkled down here. Now you can smooth this after the fact. If I hit 3 on the keyboard, or if I add another smooth after it, it won't calculate that smooth in the ncloth. It will just calculate at the lower resolution and then add the smooth after. Or if you're rendering with Arnold, then you can just add some subdivisions at render time. Okay, so that's pretty good. So you can see though how I have very little control over things. What's another way we could do this? I'm just going to turn off this airfield. See if we could do something like create a radial field. Like a negative radial field. So negative 10. Okay. Let's just say alright. Let's see, will it pull this thing in? Oh yeah. Yep. It likes that. That's interesting. So what if we put it a little bit lower? Okay, so it's being pulled toward that thing. So we could even animate this. Over some frames, pull it through here. Now that might move too fast. It might lose a hold of the cell. Let's give it a little more strength, shall we? Whoops. It likes that. So it goes, and then it should animate through. Let's see, that's kind of interesting. It gives us a little more control because we can actually move the position of this thing. We can animate its magnitude too. So I think the radial field actually works a little bit better. Save our scene, get rid of this airfield. So negative radial field. Now, actually, I think radial type. What does this mean? Who knows? But I think when you have a radial type of 1, you get a more snappy type of animation when it attracts or pushes something away. Do I see a difference? It is acting a little differently. It's more gradual. So you got too far away there. So let's put this back to radial type of 0. So the radial type of 0 seems to be more stronger, like there's no fall off over space. So we'll stick to this. Okay, so we're using a field to move it. We're using friction to make it sort of roll on the ground a little bit to get that kind of membrane cycling. Not really very accurate, but right idea. And so using the radial field gives us a little more of the leading edge going forward. Okay, last thing, let's say we want a whole bunch of bacteria floating around here that could stick to the surface of this thing. Save my scene. We'll create an emitter. And we'll make it a volume shape, cube, and have no speed away from the center or speed anywhere else. You can always change this afterwards, but let's say we put this here. Now if we play the animation, a bunch of particles will be born. Let's select these particles. And you see they're descending because of the gravity in the scene. We don't want, pardon me, we don't want to get rid of the gravity because it's helping our cell settle down onto the ground. Instead, with the particles selected, we can go into dynamic properties and say ignore solver gravity. Now when we play the animation, they just sit there. So now, once we got to the right number of particles, we could select them and go to fields, initial state set for selected, but I'm not going to do that quite yet because I actually want to instance a piece of geometry to the surface here. So I'm just going to make a little cube. I'm going to just make it more like a cylinder. Give it some height, a couple of subdivisions along the height, and then go to mesh and smooth. It's too many subdivisions, something like that. I'm going to delete its history. I'm going to scale it down a little bit, maybe stretch it up just a bit. So history, freeze transformations, and I'll put a little deformer in here. So deform, nonlinear, bend. Right. So there's a bend deformer on here now. I do this after I've deleted history, not before. I could animate this too if I wanted to have these things wiggling around. For now, I'll just do this. Let's call this something. Bacteria, bact. Now I want to instance this to these particles. So I don't select the particles, I select the geometry and go to mParticles instancer. I can open this up just to make sure, but the bacteria is selected as the first in the index of possible things instanced to that particle. Everything else stays the same. I just have to make sure that it's instanced to the right n object. Right now it's by default selected the first n object that I had created, which is the ncloth, which is the cell. I want it to go to the particle shape. Okay, so that's good. So that's like little hot dogs. Anyway, okay. So now what we want to do, and this is why we didn't set their initial state first, we want to write a little expression in the creation expressions for these per particle attributes. So if I open my attribute editor for the n particle shape here, this is the bacteria particle, and go to per particle array attributes, I want to write an expression in here based on rotation, but you'll see there is no rotation per particle attribute in here yet, so we can go down to add, say general, and by default it will open like this, but if you go to the particle tab, you can scroll down until you find rotation pp, add that, right click and say creation expression, and we will say rotation pp, capitalization matters, equals rand, so that's a command, and there are math functions in here that you can find, random functions. So there's rand, frand, denoise, noise, Gaussian. There's also, under the help menu, my scripting references, you can open the mel command reference to get access to these. So anyway, so rand 360, if you just put one value in the brackets beside rand, it will assume that you mean between 0 and 360 or whatever number you put here. End it with a semicolon, click create. Nothing happens, right? Because we've made an expression under rotation pp, which is a variable. Well, it's a per particle variable, it's one of the standard ones. But we haven't told Maya what to do with it yet. So if we go down to the instancer geometry replacement tab, down here, under rotation, we want to select rotation pp. Still, it looks like nothing happens. We've got to run the animation again. If you don't see rotation pp in there, you've got to click on this, allow all data types, for some reason. So now if I go back and play the animation, you'll see they're born at different rotations. So let's say I play it until I have enough, until I'm satisfied with my bacterial concentration. So let's say something like that. Now, if I want to freeze it in this position, I can select just the particles and go to Field Solvers, Initial State, Set for Selected. And the reason we have to do this after doing that creation expression is that if we set their initial state like this and then turn off the emitter, like we are going to do, just by turning the particle per second down to 0, then they don't have a birth state anymore because they're already born into the scene. And then if you try and run that creation expression, they're not being created, so it won't evaluate. Right? Capiche? Okay, good. So they're just sitting there doing nothing. So we can select these particles and maybe put a little field on them, like a turbulence field, and a cube, stir, create. So what you'll notice is that this field could affect the ncloth too, but I didn't have it selected when I created it. So when I play the animation now, it should just move around the bacteria, which it does, but it's a little low. Okay, so now you can see them sort of moving around here. But this turbulence is not affecting the ncloth. And the radial field is not affecting the particles because they weren't selected when the field was created. You can, after the fact, go back in and link these things up. So you do that by going to the Windows, Relationship Editors, Dynamic Relationships. And if you select, let's say, the end particle 1, which is the bacteria one, you can see stir is selected here under fields. Radial field is not, but if I click on radial field, now it will be affecting it and they'll all get pulled into that radial field. Not good. So to turn that off, just unhighlight it, dehighlight it, I don't know. Take off the highlighting for that. Similarly, for the ncloth, if I wanted the turbulence to affect it, I could click on ncloth here, highlight stir, and, well, it's kind of hard to see, but it should be being affected by that turbulence field too. At any rate, we don't want that, so we'll turn that off. Last but not least, maybe we want these particles to travel to the surface of the moving cell, or at least if they're within a certain distance, maybe they're attracted. So one thing that you can do is to select an ncloth or a particle or anything, and you can have it emit a field. So here, with the ncloth selected under force field generation, we can turn a force field along its normal. Come on. I'm going to deselect it. Okay. Normally, when you turn this on, these things become available. I'm going to select something else. Go back in here. Oh, it's because my animation was playing. Sorry. Yeah, so now that along normal is turned on, so let's see what happens. Okay, some weird stuff is happening. Oh, I disconnected the ncloth from the radial field somehow. Okay, so now it's moving. So it's kind of hard to tell, but I think it's pushing away those bacteria. Let's turn up the field distance, field magnitude. Yeah, so you can see them being pushed away by that. So we can use that to our advantage, though, and reverse the value to -1. And the field distance is how far it will reach out. So 36 here would grab almost all of it. So if we play this, you can see they're being dragged into the surface, and they're doing that kind of thing. Right? So maybe just want to reach out 5 units, so about this distance around. Let's see what happens. Interpolation linear, selected position. I don't know. Yeah, so you can see some are being attracted to the surface. And they're kind of sticking. In kind of a weirdly unnatural way. How do we fix that? I'm not sure. Well, we could try a couple of things. First of all, if we select the particle and look at its collision properties, it's not sticky, and the collision of an instance, a particle with an instance on it, is not in the shape of the instance, unfortunately. That's one thing the Maya developers haven't done yet. If I go to solver display collision thickness in the end particle shape, it shows me actually how big the collision area is, and it's just a radius out from the center of the particle. And you can change this collide width scale or reduce it. So depending on what you want to do, you can change this here, and we'll get slightly different results. And we might want to make these particles more sticky. So we don't want to make the cell more sticky, because then it will get stuck in between those two columns, I think. And see, this little guy here, he might stick to the column now. Yeah, he kind of gets pulled off the surface. So that's kind of good. I kind of like that. We could try to select the particles and go down here to rotation and compute rotation. So maybe as they strike the surface, they'll rotate. Maybe, I don't know, it might look horrible. Let's see. So you can see as it collides, yeah, so you can see that one is trying to change its rotation. Now you might get some weird, yeah, getting some weird rotations up here. So we can still work with this if we turn up the rotation damp to a pretty high number, and maybe even turn down rotation friction. So this is the likelihood that they will rotate. So with damp up higher, it's less likely that they'll rotate. That's kind of like the way it's doing that. Like they're changing their rotation because of the collisions with the floor, things like that. So that's pretty good. Now, what if you don't want these things to collide with these rigid objects, these passive colliders? Well, you can. I'm going to save my scene. You can select the particle and then shift select, one of these passive colliders, and you can use a new type of constraint called not disable collision, exclude collide pairs. And so that just says, okay, you guys don't collide with each other. And then we can do the same thing with this particle and this one, and just hit G on the keyboard. Nope. Select the particles, shift select this cylinder, end constraint, exclude collide pairs. Let's give our little bacteria a different color. Don't ever change Lambert 1 in your scene, because that's what new things are created with automatically. So if I just put a new Lambert on here, I put that on the initial object that is instanced to this particle. I can put a new material on here. I'm just using Lambert's just to make my life easier. I don't know, what color should it be? Okay. Seems a little deterministic having these things sort of sucked into the cell, but you can make it a little more subtle. Or if you had a lot more bacteria particles, if you didn't have that field and you just made them sticky, the field that's attracting them to the cell, then if they just happened to collide with it, they would stick. And you could even animate this so it was, you know, waving its arms around and things like that. And if they happened to strike each other, they could stick. So anyway, that's a lot of stuff that we've gone over in this tutorial, but it gives you an idea of how to control things like ncloth, how to animate and move around instance particles, and how to make them interact with each other. So give it a try, and if it's applicable to whatever you're doing, I really hope it helps. Let's watch it one more time. All right, thanks.